Okay guys, just another few tips on how to use Tracker. So in previous videos we identified the different point masses we were interested in and introduced the protractor. If I go up onto the left hand toolbar here, and this little blue arrow gives me all of my point masses, and you can see at the moment the chord mass B, C, D, E and protractor A. We can easily rename them, so you can see here I've already renamed the hip, which would have been mass A. So to do that, if I just click on mass B, this light blue color, and then I get a drop down box where I can just go to name. So light blue is the knee, so I'm going to name, and then in this little pop-up box which comes up, just going to replace that with knee, hit turn, and now that's changed. Okay. Now that's important just to keep track of what it is that you're actually looking at rather than just some random letters and numbers. So what kind of information are we looking for in here? So you see on the right hand side we've got our two graphs here. We can change those graphs to table views if we're just interested in numbers. The plot view is going to be a kind of better option. And if we play through, you see here I've got the protractor, which is the angle, to which what I could do is come back over here and rename the protractor ankle angle. And then down here I've got the position of the hip, so I've got degrees on my y-axis here on this top plot, and that's tracking against time. So we're looking at what degree is the ankle at each time point. So for this bit we can see that the ankle starts at around, what's that, 102 degrees, and then decreases as we go down into our counter movement, the bottom of our counter movement, and then we get a sudden increase. So this is where we've got the biggest ankle velocity increase, is during this bit, which we can we pretty much assume that is the takeoff part, that's the propulsive part. So if we play the video through and we keep an eye on this little grey square here, we'll track along, and you see there, that's the smallest angle that the ankle gets to because we're down in dorsiflexion, the bottom of the counter movement. Then we get a sudden increase during the propulsive phase. So we'll just play that again. And there through the takeoff. What I've done here is just change what normally as a default comes up as a table of figures. I've just changed that to another plot view, and then using this drop down here chosen, for this example I've just done the position of the hip on the y-axis. In other words, at what height does the hip start at what depth does it get to, and then at what height does it get to during the flight phase. So some really useful information in there. What we could also do if we wanted to create our own graphs, these can be exported, but what you can do is also create your own by just highlighting all of the information, and we could just copy the selected cells and then paste them into an Excel document and produce our own graphs if necessary. So from an assignment point of view, what we could do is if we were looking at the importance of, let's say, ankle extension in relation to knee extension in relation to hip extension, we could produce a protractor graph and look at angular velocities at each of those joints. We've only done the ankle in here, but you could then progress that to do the other joints as needed.